Okay, now my favorite thing that I have ever heard for how to divide fractions, and please use this if you like it, but it's called keep, change, flip. Have you guys heard that before for dividing fractions? Okay, so the deal is when you divide fractions, if you divide a fraction by another, dividing fractions is the same as multiplying by the reciprocal. And the reciprocal of a number is just the number flipped over. For example, so if I had 3/4, its reciprocal would be 4/3. When you multiply reciprocals together, they actually end up being 1. So the keep, change, flip, if you're dividing one fraction by another, if I keep the first fraction the same, change the division to multiplication, and flip the second fraction over to give me the reciprocal, that would be how I would want to do the problem. So that's what the keep, change, flip is. So I just have a little example right here below with numbers. So I'm taking 2/7 and I'm going to divide that by 4/5. So I'm going to keep the 2/7 the same. And I change the division to multiplication. That's the keep, change part. And then flip gives me the reciprocal of what I was dividing by. So if I do 2/7 divided by 4/5, that's the same as 2/7 times 5/4. And then once you have a multiplication with fractions, you don't need a common denominator. You literally just multiply straight across the top. So like 2 times 5 is 10, straight across the bottom. 7 times 4 is 28. And then if you can reduce it, you would want to. So in that case, let's see, both of those numbers are divisible by 2. So 5/14 would be reduced version of that. But that's the easiest way I can tell you how to do division, which is what we're going to work on today, but with a little bit more complicated expressions. Okay, now the only other thing I have to remember, dividing rational expressions, restrictions. Okay, so we do not, I'm going to write no denominator equal to 0. We want to exclude anything that would make our denominator equal to 0. Now, the one thing with the division, this is at any point in the problem. So, when you're dividing and you've got an expression that might have some variables in it, whatever you're dividing by, you actually have to exclude the top and the bottom of the fraction, because anything that would make any denominator 0 is an issue. So I'm going to kind of try and see if I can keep like a little running total of the restrictions as we go through here. So here is my first problem. So this is fraction divided by fraction. That looks very complicated. I understand that. Let me just have you guys look at the very top of that fraction. I'm just going to cover up the bottom for a second. So in the denominator, it's not something we're going to factor. I just have x to the third and y to the second. So I'm going to just kind of write these over to the side here real quick. In that, just the top of that problem, what numbers would I plug in for x or y that would cause our denominator there to be 0? Like x can't be what? If I have x cubed times y squared, what do I not want x to be? 0. Okay? Now, what do I not want y to be? Same thing. Okay. So 0, 0. Okay, now I'm going to look at the bottom of this fraction. Now, just the bottom of the fraction, this is what I'm dividing by. And I have 8x to the third. What number would cause me a problem in the bottom of that fraction to make the denominator 0? 0 again. It's just like 8 times if I put in 0 squared. So we've already written that down, so we don't need to write it again. Okay, now I'm going to do my keep, change, flip. So I'm going to keep the top fraction, this 20x minus 5y over x cubed y squared. I'm going to change that division sign to multiplication. And then I'm going to take the fraction I'm dividing by, I'm going to multiply by the reciprocal, so I'm just going to flip it over. So what will happen there, the 8x to the third is going to go on the top, and the 12x minus 3y is going to go on the bottom. Okay, before I actually try to multiply this, I just want to do a quick thing. You really can't factor anything on the bottom of this first fraction or the top of the second fraction because I don't have any, it's just a single term, so nothing to factor. But let me just have you look at the top of this first fraction. I have 20x minus 5y. Do 20x and 5y have anything in common? 5. And it doesn't matter that they're different variables. Both of those numbers are divisible by 5. Okay, so on the top of that, I'm going to take a 5 out of both of the terms. So if I do 20 divided by 5, 20x divided by 5, that'd be 4x. And I'm going to keep the subtraction in the middle. If I divide 5y by 5, that would just turn that into a y. All right, and I've got this x cubed, y squared on the bottom. I'm not doing anything with that. Now, I'm not doing anything with 8x cubed on the top of that other fraction either. But let me look at the bottom there where I have 12x minus 3y. Do 12x and 3y have any common factor? Both divisible by 3. The 4 is going to be the leftover. Okay, 12 and 3 are both divisible by 3. Okay, so on the bottom here, I'm going to take out a 3. Now, 12x divided by 3 would be 4x, and then 3y divided by 3 would be minus y. So I know it didn't look like this initially, but we're going to be able to cross some stuff out here. Okay, so once I'm just multiplying, which that's what I'm doing here. I did my keep, change, flip. I'm multiplying by the reciprocal. I'm going to cross out anything that matches up. So I have a 4x minus y and a 4x minus y, so they're going to cancel. I also have x to the third here, x to the third here cancels. Now, what I would have left, on the top I have a 5 and an 8, so I'm just going to multiply 5 times 8 is 40. On the bottom, I have a 3 here, and I have a y squared, so I'm just going to write that as 3y squared. And in terms of my restrictions, what ended up in the bottom here, the only other thing we're going to need to restrict, let's see if I can kind of highlight this for you. So the only thing, I've already taken care of x can't be 0, y can't be 0. This ended up in the denominator, and I would take it from the factored form. It's a little weird because you have two variables, but I don't want 4x minus y. I don't want that to be 0. If you want to just write it like that, that's completely fine with me. That's a restriction. Or sometimes if you'll see this like in a textbook or something like that, they might kind of almost like do a step to solve that equation. They might write it just like to add the y. They might say 4x cannot be equal to y. Either one of those would be good as a restriction for that situation. That's a really hard problem. Does anybody have a question? Okay, the rest of these are not nearly as bad as that was. Okay, now, this is nice for us because it's already been factored. Don't FOIL anything, okay? So I'm just going to look at this. This is a division question. So the first thing I might do before I do my keep, change, flip, at any point in the problem, you cannot have the denominator be 0. So I'm just going to write some restrictions real quick. In this first fraction, I have x minus 4 on the top. Don't worry about the top. You're just going to worry about the denominator. So this 3x minus 2, x minus 2, and I got an x minus 2 again, and an x minus 5. Those are the places that could cause my denominator to be 0. Okay, so what would you tell me if you had 3x plus 2? What would I not want? That one's really tricky. What would I not want x to be? 2 over 3. I'm just going to make it negative. Like if I set that equal to 0, you would subtract 2, divide by 3. Okay, just x minus 2 is just going to be a 2. X minus 2 is just going to be 2 again, so I don't have to write it twice because it's going to be the same. And x minus 5 would be 5. So I'm just going to write a little list over here to the side. So negative 2/3, positive 2, positive 5. You don't have to write them in a particular order. Okay, now I'm going to do my keep, change, flip. So I'm going to keep my first fraction the same. Just don't FOIL it. We want to leave it in factored form because we're just multiplying here, so we want to see what would cancel out. I'm going to change that division to multiplication, and when I flip this over, what I'm doing is multiplying by the reciprocal, which is how I want to divide these fractions. And whoops, I have a 5, and then x minus 4. Okay, now, if I'm just multiplying these together, this just turns into one giant fraction. So anything on the top and bottom, if the factors match, since everything's being multiplied now, we can cross it out. So I got an x minus 4 and x minus 4. I've got an x minus 2 and an x minus 2. Nothing else matches. So just whatever's left. On the top, I have x minus 5. You can write it like that. You could put parentheses around it. It's up to you. On the bottom, don't need to multiply this out. I do have a 5, and I do have a 3x plus 2. So I would want to put parentheses around the 3x plus 2. If you want to multiply that and write 15x plus 10, that's okay, but you can just leave it in factor form if you want to just save some time. And then the only other thing I got to just really quick check, when I flipped this fraction over, that put this x minus 4 in the denominator. So even though I canceled it out, I'm going to have to add 4 to my restrictions there, because that ended up in the denominator. At any point in the problem, if you have something in your denominator, you've got to exclude if you plugged in a number for that variable, and it would make it 0. Does anybody have any question? Okay. We're just going to factor these real quick. All right, and I'm going to go through it real quick because we don't have a ton of time because I talk too much. All right, on the top of this, I got to multiply to get negative 15 and add to get 2, so I'm going to use 5 and 3. I'm going to use x plus 5 times x minus 3. Those two numbers will multiply to give you negative 15, add to get you 2. The bottom is the difference of squares, so multiply, get negative 16, add up to 0. We're going to use 4 and negative 4. Okay. Now, I might, just to save myself some space, this fraction we're going to flip over. The only thing that can be factored there is the bottom of that fraction, and that would just be to take out a 3. 3x and 12 both have a 3 in common. If I take out a 3, that's going to be x minus 4 in the bottom. Nothing to factor in the top of that. So I'm just going to go ahead and do my keep, change, flip all in one step here. So I'm going to keep that first one, change this to multiplication. That 3 times x minus 4 would end up in the top, and that x plus 5 would end up in the bottom. All right, now, once we've got that, this is just all being multiplied. No common denominator needed. Just if anything matches up, we're going to cross it out. All right, so I got a x minus 4, x minus 4, x plus 5, x plus 5. On the top, I've got a 3 and an x minus 3. And then on the bottom, I've got an x plus 4. Nothing else is going to cancel out there. And then for my restrictions, I'm just going to go back real quick. At the beginning of the problem, I had x plus 4, x minus 4 in the bottom. So we don't want 4 or negative 4. And then for the second fraction, before I flipped it over, we had that 3 times x minus 4. I've already taken care of 4 because that ended up being in the bottom of this first fraction, so we don't need to write it again. But then when I flipped it over, the x plus 5 ended up in the bottom, so then I do need to add negative 5 into my restrictions. Sorry, I'm trying to do these real fast to give you guys some time so you can try them out on your own. All right, the top of this next fraction, I've got 4x squared minus 2x. Both of those numbers divisible by 2, and both of them have an x. Left over, I would have 2x and then just minus 1. I'm just taking out a greatest common factor there. Okay. Now, the bottom of the second fraction, all those terms are divisible by 3 and also an x. Left over there, I'd have x squared minus 2x minus 3, which I'm going to be able to factor that a little bit further, but let me go ahead and factor the second one here. Okay, multiply to get 12, add to get 8. You're going to have 6 and 2. And on the bottom, I've got negative 18, multiply to get negative 18, add to get 3. So it's got to be positive 6 and negative 3. Okay, the only other thing you can do here real quick on this very first fraction, you can factor what I had left over here a little bit further, this x squared minus 2x minus 3. That can be factored into multiply to get -3, add to get -2, x minus 3, and x plus 1. So that can be factored just a hair further. All right, let me go ahead and write my restrictions, and then I'll flip that over. So at this moment, we don't want x to be. Now, plain 3x, people do this all the time. They'll tell me 3. No. If you just have 3 times x, what would you plug in for x that would make that a problem? Not 3. What would you plug into 3x to make a problem here? If I just had 3x in the bottom of a fraction, what do I not want x to be? 0. Okay, don't put the number. People do that all the time. 3 times 0 would make that 0. Okay, now, next to that, I had -3, so +3 would be the restriction. Then I had a +1, so -1 would be the restriction. In this fraction, I got x plus 6, so -6 is going to be a problem. And x minus 3, I've already written 3, so I don't need to write it again. All right, I got 2x times 2x minus 1 over 3x times x minus 3, x plus 1. We're going to divide that, or sorry, I'm going to keep that. I'm going to change this to multiplication. We're going to flip this other one over. Now, I could have canceled out the x plus 6's at any point. They're within the same fraction, so I didn't need to rewrite that in that step. But anytime you want to do that, if they're in the same fraction, you can cancel them out. I just wanted to show you where it came from. So those are going to go x minus 3, x minus 3. Now, the only other thing that I can cross out there is what? There's one other thing I can get rid of. Just the x's. I know that's right, just the x's. So the 2 and the 3 would be left. Okay, so on the top, you're going to have don't just leave it in factored form. That's fine. You have a 2 and a 2x minus 1. On the bottom, I have just a plain 3 because that x is going to cancel out. You have an x plus 1 and an x plus 2. Do not worry about foiling that out. Just leave it in factored form. I'm not trying to make it more difficult for you guys. If you can factor it, just leave it in that format. And then I just got to go back really quick. The only thing I would add to a restriction here, when I flipped this second fraction over, that introduced x plus 6 and x plus 2 into the denominator. I've already excluded -6, but I do need to add on that -2 is now a problem as well when I flip that second fraction over. Okay. I'm going to try and do one more just with you real quick. All right. Let's see. Now, this one does have one with a 2 in front of the x squared. So I'm going to do the top real quick. Multiply to get -2, add to get -1. So it's going to be x minus 2, x plus 1. Multiply to get -22 and add to get 9. Let's see. I'm going to do 11 and -2. Those will multiply to give me -22, but add to give you +9 because I've got +11 minus 2. Okay. The top of this is pretty quick. Multiply to get -12, add to get -1. So I'm going to do -4, +3. The bottom of this fraction is a little bit harder, so I'm going to do that little Berry method. And if you like a different method for doing this, please feel free. But I'm just going to start out, and the Berry method would have you take whatever the first term is. I've got 2x squared. Just drop the squared. Put that at the beginning of each of the factors. This won't be the correct answer, but it's the fastest way. Excuse me, I can get you there. All right, I'm going to multiply the first thing times the last thing. So 2 times -3, -6. Add to get the number in the middle, which is 5. Okay, only way to do that is I got to use a +6 and a -1. Those will multiply to give you -6, or -1 times 6. Add to get you 5, though. +6 minus 1 is going to be 5. Now, 1 or both of these is not the real factor. It's just 1 here. This 2x plus 6, since both of those are divisible by 2, the real factor, just divide both by 2. X plus 3, and then 2x minus 1. those two terms don't have anything in common, so that'll be the real factor. And I always just check real quick. So x times 2x give you back the 2x squared. 3 times -1 will give you -3. You should be okay. I'm going to come over here and write that down real quick. X plus 3, 2x minus 1. Okay. Right away, I'm going to go ahead. Those x plus 3s are in the same fraction. These x minus 2s are in the same fraction. So I'll go ahead and cross those out. And then we're just going to do our keep, change, flip. So I'm going to keep this x plus 1, x plus 11. Change this to multiplication. Flip this over. 2x minus 1 and x minus 4. And then in this particular case, nothing else is going to cancel out. So I'm just going to leave it in factored form. I'd have x plus 1, 2x minus 1 on the top. And I'd have x plus 11, x minus 4 on the bottom. Nothing else canceled there. There was nothing else that matched up. And then my restrictions. Okay, let me go back. My original problem, I got -11 as a problem, +2, -3, and that 2x minus 1, I would add 1 and divide by 2 if I set that equal to 0. So that's going to be 1/2. And then the only other thing I got to worry about when I flip that fraction over, I already had the x plus 3 taken care of, so don't worry about that. The only other thing that ends up in the bottom is x minus 4, so I would have a 4 as part of that restriction. So if you're dividing, it's really the restrictions at the top and the bottom of the second fraction. But otherwise, it's really similar to what we were doing in our last set of notes. Just got that extra step where you're going to flip over the second fraction and then multiply.